I'm gonna be solving 4.3. So here they show us an electrochemical cell and they ask us what's missing. It's the salt bridge. You need it, or else the charge is gonna build up and it's not gonna do anything. So the salt bridge is used to like make the charge even out and pass out and not let it build up. Which one of these is oxidation half reaction? This one is a full redox reaction. It's not just half. This one is reduction. This one I'm not too sure, and this one it's just acid plus base. So here is the only one where it's losing electrons. So look here, spontaneously just means naturally, so like without any external forces forcing it to happen. So zinc is the most likely to become oxidized and silver is the least likely. So here I'll show you an example. Copper plus zinc. Zinc is more likely than copper, so it should be the one losing electrons. Should be solid on the left side and an ion on the right side. This is the opposite here. That's why it's correct here, because it has a higher tendency to lose electrons than copper. So it happens here. Here it's not balanced, and also the same thing, hydrogen is higher, which is why it's like that here. Here silver is the lowest, so it shouldn't happen. And here it doesn't make sense. It looks like it makes sense at first because zinc is losing, but look, how can they both lose? One of them has to gain. That's the whole point of redox. One of them loses, the other gains. The electrons can't just disappear. So here it's an electrochemical cell with manganese and tin. So they're just asking us like which is the anode, stuff like that. So tin is the positive. The positive terminal is in an electrochemical cell is the cathode, not electrons. In the electrochemical cell, the tin, the positive terminal is the cathode. Also, if you don't remember that, you can remember it from here. Manganese is more reactive. The more reactive is the anode. You can remember either way. So the electrons flow from the anode to the cathode. You have to remember that, because it's like this. Let's for example say we have two metals A and B. A is the anode, B is the cathode, and the salt bridge and everything. So you have metal A and you have metal B. This is the anode and this is the cathode. So because the anode gets reduced, remember, look, it's there's a way to remember it. It's like, remember animals, anox, so anode oxidation, and red cat reduction cathode. That's the way you can remember it. So look, so that means that metal A loses because it's at the anode, so it becomes A plus plus E minus, and then this one it's B plus plus E minus becomes B. So that means the electrons are getting released here. It goes from the metal to the electron. So where else would the electrons come from? Because here, see, it's taking the electrons in, so it has to go from here to here. There's no other way. And the current flows opposite to the electrons. Just remember that. Cathode is tin, anode is manganese. We already talked about it. The cations move towards the tin strip, while the anions, yeah, okay, look. So I'll redraw it fast. So you have A becomes A plus plus E minus. Forget the salt bridge for now, I just want to show. So it becomes B plus plus E minus becomes B. Look, so here there's a bunch of positive ions. Yeah, the electrons are going from here to here, so ignore the electrons. So in the salt bridge, where are they gonna, here it's like way more positive than it is here. You have to even it out so the charge doesn't build up. So what happens in the salt bridge, this is the salt bridge. What happens is the anions go here to neutralize these, and the cations go here so it can make the neutral a bit more positive to even it out. Oh no, sorry, the other way around. So anions go here to neutralize it, and the cations go here. So anions go to the anode, cations go to the cathode. Remember it like that. Oxidation half reaction, oxidation at the anode and it loses. So oxidation involves losing, reduction involves gaining. at the cathode. So here zinc is a positive terminal, so that means it's the cathode. So that means the electrons go from the anode to the cathode, like I showed you in the last question, and the current goes the other way. So here the current goes from the cathode to the anode, and the electrons go from the anode to the cathode. See here, it shows here. And then you add the oxidation and the reduction, you just make sure it's balanced. And here they're asking, this is what we took in physics, V equals W over Q. I don't know if you guys remember, but here they use W as E. So V equals to E over Q. Like that. So yeah, so we have V, it's given here at the top, it's 0.9. So 0.9 equals 2 E over 2. Yeah, okay. So we have V is 0.9, Q or charge is equal to 2, E is equal to question mark. E is the same as W. If you remember from physics, if you want to remember from physics, it's V equals W over Q. So that means V equals E over Q. So 0.9 equals to E over Q. Q is given, sorry, 2, cross multiply. E equals to 1.8. Okay, here you have to use stoichiometry. So 0.6 moles of zinc react with chromium. Calculate the number of moles of chromium deposited. So it's what's called, the formulas, I'll show it now. I don't think it shows here. Yeah, here. So the moles, yeah, okay, you can tell here, it was the moles dissolved equals to the moles deposited. So here 0.6 moles reacted, so they're asking how many moles of chromium were there. So here you have 3. Let me you have 3 here and you have 2 here. So if 3 gives you 2, yeah, okay, here. So if 3 gives you 2 and 0.6 gives you X, let me write here, it's gonna be more clear. So 3 gives you 2, so that means 0.6 gives you X. Cross multiply. 1.2 equals to 3x. Divide both sides by 3. 1.2 is equals to 0.4, which is what we got. And then they want the mass. They already give you the molar mass, so the number of moles equals mass over molar mass. Molar mass of chromium is given. So 0.4 equals to X, we don't know the mass, over the where's the molar mass? 52. That's it. So what's called, you cross multiply. 52 equals to 0.4 X. Yeah, I think. No, wait, my bad. So yeah, okay, it's not like that. It's 0.4 over 1. So then like that. So then X equals 0.4 times 52. Let's see, so 0.4 times 52, you get 20.8. Lead metal reacts with copper ions but not with nickel ions, while magnesium reacts with both copper and nickel. drag and drop to arrange the following half reactions, decreasing tendency for metals to lose electrons. So it's basically asking which one is the most likely, which one is the most likely to lose electrons, and 4 is the least likely to lose electrons. So look, lead reacts with copper ions but not nickel ions. That means Pb plus Cu2 plus works, but Pb plus Ni2 plus doesn't. So that means that nickel is more likely to lose than lead. Because if it was like that, then lead would lose its electrons and give it to nickel. But here it works because lead is more likely to lose than copper. So it's gonna become Pb2 plus Cu metal. So we already know that nickel is so we don't know where they are, but nickel is above lead and lead is above copper. And they also tell us here magnesium reacts with both the ions. It's important that they say ions. So look, so Mg plus Cu2 plus and Mg plus Ni2 plus. So that means magnesium is the best at losing. So it's like that, see? 1 for magnesium, 2 nickel, 3 lead, 4 copper.